3.3 part 2. If you have not watched part 1, go back and watch part 1 of 3.3, the polynomial division. So we just got done talking about long division and synthetic division. So let's talk a little bit further about a theorem that's going to come in handy as well. It's the remainder theorem. So if you have a polynomial divided by a factor x minus c, then the remainder, so whatever remainder we have, that's actually the value of p of c. And you're like, what in the world was that talking about? Well, let's do a problem, and then you'll see exactly what I'm talking about. So here we have, we're going to use synthetic division. So 3, 5, and synthetic, we're just going to write the coefficients. Something I do want to point out, notice it went from 5, 4, 3, the exponents, 5, 4, 3, and there is no 2. So, there's no 0x squared. So we need to include the 0, and then 7, and then 3. And the factor is x plus 2, so we're going to use x minus 2. Remember, if we set that equal to 0, then the x would actually equal -2. So we're seeing if -2 is a 0. So here, if I divide by this, bring down the 3, and then again, I want you to bring that down, multiply, add until the end. So that's going to give me -6, add, that's going to give me -1, 2, -2, -2 times -2 is +4, 0 plus 4 is 4, -2 times 4 is -8, -8 plus 7 is -1, -2 times -1 is 2, and I end up with a remainder of 5. This means the remainder is 5, so let me highlight that. That's the remainder, and once I have that, that means I know if I substituted p of -2 in, remember I took -2, so if I put -2 into the polynomial, the answer would be 5. So this literally is the same thing. If I put 3 blank to the 5th power plus 5 blank to the 4th power minus 4 blank cube plus 7 blank plus 3, if I put -2 in for x, I'm going to get 5. So that's really what this is if I take p of -2 and I end up getting 5 as the remainder, that's the same thing as if I plug -2 into the function. So I could ask you find p of 0. Well, p of 0, you can see if I plug 0 in, it's going to give me 3. Well, if I did synthetic division with a 3 out here, then I would end up getting, or with a 0 out there, then I would end up getting a 3. If I did a p of -3 or p of 8, or, it's the same as if I plugged it in, and then the remainder, what's left over, is the same thing as if I plugged it in, it's the same thing as if I use synthetic division and looked at the remainder. So again, that's what the remainder theorem talks about. So it literally says if p of x is a polynomial is divided by a factor, then the remainder is the value, same value as if I plugged it into, if I plugged the c into the polynomial. And then let's learn another theorem. It's called the factor theorem. So and we've already mentioned this. I mentioned this a couple problems ago. So if c is a 0 of the polynomial, if and only if, that's what IFF stands for, if and only if, x minus c is a factor of p of x. So, and we've already mentioned that, so if the x minus c is a factor of it, so if we absolutely know it does factor, then we know that the c is a 0 of that. So let's look at an example here. So here I have x cubed. Let's not ready to do long division, but let's go ahead and use synthetic division. So 1, and then notice there is no x squared. So I'm going to put a 0 and then -7 and then 6. And then because this is x minus 1, I'm going to use a 1 out here. Remember, let's set that equal to 0 because I'm trying to see if this is a 0. So bring down the first number and then just multiply, add, multiply, add, multiply, add. So 1 times 1 is 1. Add that, that's 1. 1 times 1 is 1. -7 plus 1 is -6. 1 times -6 is -6. And notice whenever you get a 0 as the remainder, that means this factored perfectly, and it is a 0. So literally x minus 1 is a factor, and this is, remember I started with x cubed, so this is 1x squared plus 1x minus 6. And of course, this factors even further, because now you got it down to a quadratic, so you should be able to factor this. So notice a couple things. If you use synthetic division and you get it all the way down to a quadratic, then you can factor the quadratic or use completing the square or the quadratic formula, but you could get the answers after that to be able to do that. But it factors, and because it factors, now if I set those equal to 0, I can see that x equals 1 is a 0, which I already knew that, but now I see that -3 is a 0, and I also see +2 is a 0. Again, based on the factor theorem. So if c is a 0, then the x minus c is a factor. And again, if and only if means it can be read the other way around. So if x minus c is a factor, then c is a 0. So that's, I can find the zeros by this, I can factor. So, if I ask you to factor all of this using synthetic division, then I'm looking for this answer. If I say find the zeros, then I'm looking for this final answer as well. All right, and then finally, let's look at the last example. It's like an extension problem from what I just went over. So here it says find a polynomial with zeros -3, 0, 1, and 5. So here, I'm not giving you the polynomial, but here I'm giving you the zeros. Well, we know zeros, if -3 is a 0, that means the factor is x plus 3. If 0 is a factor, then x minus 0, 0 is a 0, then x minus 0 is a factor. If 1 is a 0, then x minus 1 is a factor. If 5 is a 0, then x minus 5 is a factor. So again, this is, now what I need to do is, the fun part is I need to multiply all of that out. So we're going to literally just, this right here is just x, okay? So this is going to just be x squared plus 3x, multiplying these two guys together. That's, again, this is just x. And then what I'm going to do, if I FOIL those two together, I'm going to get that. And then I'm going to multiply now finally the binomial times the trinomial. And then I'm going to get that expression. Now, did you notice at the beginning, I didn't read the rest of the problem? I said find a polynomial with zeros here, and I didn't read the rest of the problem. So here I found a polynomial with those zeros, but it also says x cubed has a coefficient of -6. So notice x cubed is right here. And notice the coefficient is not -6, it's a -3. But I wanted to have a -6, which means everything needs to be multiplied by 2. So this is 2x to the 4th minus 6x cubed minus 26x squared plus 30x. So notice I found the polynomial that I'm looking for that has these 4 zeros, and it has a coefficient, x cubed has a coefficient of -6. That's this is part 2 of 3.3 video. So make sure you watch part 1 and part 2 about polynomial division.